This video will demonstrate the O2I4 series IO-Link code readers from IFM. We'll be integrating it into an IFM IO-Link master and into an Allen Bradley PLC using an add-on instruction that has been created for it. I'm going to go into Mineo Configure to see how it is connected to the IO-Link master. I have the O2I400 on port 1 of an IO-Link master. We can click on the O2I400 and see the data that's available. When I'm reading in this video, we'll see that I'm reading a PDF 417 type code, and I'm also reading a code that has a large amount of data on it. It has 198 bytes of payload. What we'll see here with IO-Link, we are limited to 32 bytes of data per port. Some of the data is used for triggering the camera and other things necessary for the function of the camera, and the payload is limited to 14 words or 28 bytes of data, and that's shown here by the light green section. So what the camera enables you to do is to cycle through many times. So we're going to grab 28 bytes of data until we build up our full code. And this will be handled by the add-on instruction. We're going to go into the Vision Assistant software, and the Vision Assistant software is used to configure the camera. So this is where you'll go through and add an application and define the type of triggering that you would prefer, and also teaching it the codes. I have two applications set up. They're both reading a PDF 417 with the same code. Application 1 is a continuous style trigger. Application 2 is a process interface trigger, meaning the PLC will be sending the trigger command to the camera. When you are reading large bytes of data, more than 28 bytes of payload, we need to go to the device setup, interfaces, and we do need to make sure that IO-Link enabled segmentation. This allows the camera to cycle through and get the data, the full data, to your PLC. So I have made this change. If you do make a change, you will need to save and reboot the camera. Going back to the applications, we'll see that I have application 2 active currently, and this is my process interface trigger. So if we went to edit application, we would see the process interface trigger. Let's go to monitoring, and now the camera is ready to be triggered. Going into the PLC, I have just made a download to the PLC project so we can see the add-on instruction from its initial state. To set up the add-on instruction, you'll need to give it an instance name, and then also the PLC input and output arrays. These PLC input and output arrays come from your controller tags. When you set up the IO-Link master in the PLC, we'll see that we have a configuration tag, input and output tag. The add-on instruction is asking for the data array for the input and also the data array for the output, and we'll see that this is a data array of 123 words and also 87 words for output. So this is what has been pulled into the PLC input and output. Lastly, you'll need to input the port number. I am on port number 1 as shown in Mineo Configure earlier. So this could be for 4-port IO-Link masters, a value of 1 through 4, and of course for 8 ports, 1 through 8. For receiving the data, we do have the evaluation results data. This is a user-defined tag, so I have called it evaluation results, and we'll see that this is defined as a 442 byte array. There are no errors on the rung after you have defined these 4 things, and we can now go to run mode. The first thing that the add-on instruction is going to do on the first scan is it's going to go out and read the information from the camera. It'll read the active application number, the total number of applications, and we'll see here that this matches what is in the Vision Assistant. My active application is application number 2, and I do have 2 total number of applications on the camera. On the right hand side, we'll see that we have the camera command ready bit. This means that any trigger is ready to be set by the user as long as the camera is ready for a trigger. We'll also see once we do set a trigger, we'll have a command busy bit. This will let you know that the camera is processing a command, and the appropriate done bit for the command that you have set will be set once the command has completed and any payload information is ready for you to read. As with any other IO-Link device, towards the top we have the same settings. We'll know that the port is in IO-Link mode. When you disconnect the device from the IO-Link master, the device is not connected, so that means the port is looking for an IO-Link sensor, but when it's not connected, we'll see the device is not connected. Invalid data means that the data is out of range. Wrong vendor ID and device ID, and diagnostic of available. These two things usually go together. When you have automatic device replacement set, which is the data storage settings in the configuration of the IO-Link master, if you plug in the incorrect device, meaning you don't have the device of 1699 connected, maybe you plugged in a different type of sensor, that different type of sensor would have a different device ID, or if you plugged in different manufacturers, the vendor ID would change and this warning would come up. But you do need to set that up in the configuration of the IO-Link master. By default, there is no data storage settings, and you can plug any sensor, IO-Link sensor, into the port. The diagnostic available bit will usually be used if any IO-Link events happen. Most likely, the event that's most common when automatic device replacement is set will be that the diagnostic available bit will go true when the parameters are being restored. So it's an indication that automatic device replacement has been set. The AOI settings error, means that there's an error in one of the user inputs. For instance, if I have a 4-port master but I change my port number to 5, we'll see that an AOI settings error. So this means a user input has been done incorrectly. Other things that may happen if you have more than one trigger true at one time, then you'll get an AOI settings error. So this is an indication that the add-on instruction has an incorrect setting within it. We're now ready to set the evaluation, and we'll see how the camera responds. So this is a rising edge trigger, or any of the triggers are rising edge. But I'm going to manually set it here. We'll see that the command has gone busy. This means that the sensor is processing the command, and it's taken a little while because it's setting all 198 bytes of data. Now I have the rising edge of evaluation done, and we can monitor the results. Looking at the data in ASCII, we'll see that I have a string of information from 01, 02, and as we scroll down, we'll see it goes all the way to 98 and 99. So here is my 198 bytes of data that I was mentioning earlier. And we also have 2 more bytes of data, and that's appending the total payload. So if I change this to decimal, we'll see that this is a -58. Or if we change it to hex, we'll see that it is a value of C6. A value of C6 in decimal is 198. So this is where my 198 bytes of payload is shown here. So 0 to 197 is 198 bytes, and the length was also appended. We can go into the Vision Assistant to see how the mapping of the evaluation results is set. If we go into Application, click the application that we would like to edit, and click Edit. Now we'll click down to Interfaces and open up the IO-Link interface. Here is the user settings of how the evaluation results is set. We'll see that the first thing that comes through is the content. The content is the output string. So this is my 0, 1, 0, 2 all the way to 98 and 99. Then we are appending the byte content. So here is the number of bytes in the content, and when I edit it, we'll see that I have an integer 16. This is why the bytes produce 2 more bytes of data, because I have set it as an integer 16. I could also change my settings here, and of course that would change the mapping inside the PLC. So going back to the PLC, here is my byte array, and then we'll see my appended number of bytes in the content. Now what we'll do is we'll change applications. So let's go back. We'll see that we're on application 2. Now we're going to go to application 1. Just as a note, in the application 1, I have switched the process interface so that the number of bytes of the payload comes in first. So now we're going to look at this application. We'll go to interfaces, open up IOLink, and now we'll see the number of bytes in the content is first, and then the content of the payload will come through. So this is a way that we'll be able to see the differences as we switch back and forth in the applications in the add-on instruction. So we have application 2 active currently. We'll go to the monitor. We'll set our trigger low, and now let's change applications. So here we'll need to set the application number we would like to go to. By default, it's set to 1, and we're going to use a rising edge of the change application trigger. We'll see the same behavior here. The command busy bit will go true. The get app info underscore done will also go true. So we'll know that when this is the rising edge of this is true, then we'll know the applications have switched. The add-on instruction also does evaluate if the camera is triggering by itself. So we'll see this continuous or hardware trigger mode bit be true if you have either a continuous trigger or you select a positive edge or negative edge trigger in your trigger configuration in the Vision Assistant. We'll see that the evaluation done bit is toggling on and off. So this is because it's building the evaluation results, and when all 200 bytes of data are collected, then the evaluation done bit goes true. So now let's monitor our evaluation done bit true, and now we'll see that the length of data is now appended first. So what we'll do is we'll zero some of this out. So what we'll see here is when the evaluation done bit has gone true, this data will repopulate because now it's building it. So it builds at 28 bytes at a time. And if we scroll down, we'll see that all of our data is now true, and it will come down all the way this time to 199. So there's my full 200 bytes of data. Some other features in the add-on instruction will be to manually get the application information. So each time you reboot the camera and plug it back in, when the camera is ready for a trigger, then the add-on instruction automatically goes out and gets the application info. So it will automatically, on first scan, get the application info. It will also get the application info on a reboot. And also when you change applications, we'll notice that it also updated the active number of applications. So here, if I set the trigger low again and go back to application number 2, we'll see when the change application has been done, it also updates the get application information done here, and we'll see that this has changed back to a 2. And it's no longer triggering, so the continuous hardware mode, trigger mode, will go low again. So let's change it back and look at some other information that we can get from the camera. The get statistics trigger will get the current statistics from the camera, meaning the total passed and failed readings. So here, again, a rising edge trigger will show the total passed and failed readings. I have now set my hand in front of the camera, and now I should have some failed readings. So I'll go out and get the application get statistics trigger again. And now we'll see that I have 5 failed readings after I put my hand in front of it. And you'll see the total of the passed and the failed equal the total readings. If I'm ready to reset the statistics, I can use the reset statistics trigger. And now when I get my new statistics again, my new values show up here. The last thing I would like to show is how to use the command ready bits and the done bits so that there are no timers if we want to essentially create a continuous trigger, but we want to use the process interface trigger instead. This is very common if I don't want the camera just to trigger all the time. I only want it to burst for a certain amount of time as maybe a product comes through and I don't want to see the flashing of the camera. So here let's change it back to let's set all of our triggers to 0. Change our application to a 2 and change our application. I have some logic preset up here and it's just a simple 2 rungs of logic, and this will show us how to use the add-on instruction output bits to continuously trigger the camera. It will also show how the triggers can be used on a one-shot trigger. We don't need to hold the trigger true until the commands are done. It's one shot. We'll use the done bits to know whether when the camera evaluation has been completed or any other command has been completed. I have set up this rung 1 here, and this just shows every time the command ready bit goes true. I show this because each time that I have triggered the camera, this toggles 1. So sometimes we don't always see the camera ready bit go true because it happens fast or the done bits happens fast, but we are seeing indeed that it is resetting and the done bits are resetting each time a trigger is set. So let's take a look at the logic that's been set up here. I have the X1 bit here. When this goes true, this is going to look for the command ready bit to go true. If the ready bit is true, then I am able to send a trigger. So here I am setting the evaluation trigger. Once the evaluation done bit has gone true, then it's going to unlatch the trigger. We'll come back again and make sure that the camera is ready for a trigger, and the process will start over again. So this is essentially how I'm going to make this process interface trigger continuous. What we'll also see is the command ready bit will be going true and false each time that the done bit has gone true. Then the camera will signal that it's ready again, and once it's ready again, that's going to cause our rising edge trigger. So let's go ahead and set output or X1 and watch the behavior. So here we've gone busy. It's now building the 200 byte array in the evaluation results, and as soon as it goes done, the camera now triggers again. So here we can see that the camera is triggering even though we didn't see the ready bit come true. This is an indication that our evaluation results have been done. If we do want to monitor the evaluation results, we can see that the data is being populated again. Again, this is where the length is appended at the end of the code, but if I zero some of this out, we'll see that the data comes back. So here it is now refreshed, and I am continuously polling as fast as the add-on instruction can, because as soon as the done bit goes true and the data has been set, I start the whole process over again. When I'm done completing my time of, I'll call burst, then we'll see that the evaluation goes done, the camera is ready, and we're ready to do any other functions that have been previously shown in the add-on instruction. So this add-on instruction gives you the full capability of changing applications, getting statistics, getting the evaluation results, and switching applications, and so you should be able to integrate this into your PLC logic with ease.